In this video, we're going to be looking at adding and subtracting radicals and solving radical equations. So in the previous videos, we saw simplifying radicals, we saw multiplying and dividing radicals. So adding and subtracting radicals is actually very similar to how we would add and subtract polynomials or monomials. So we're looking at the idea of like terms. So the first thing we do is we look to treat each of these as its own term. So 2 root 2, 3 root 2, 2 root 2, and we're going to see if they're completely simplified. So it turns out all three of these are simplified. So square root of 2, we can't go any further. We then look to see which of these are considered like terms. So anytime we have a simplified radical and the value or variable underneath there is exactly the same, those are considered like terms. So when we're adding these are actually all terms we can put together. And so we don't actually touch the radical 2 since it's simplified. We are simply just adding and subtracting those coefficients, right? So anything I have in blue, I'm going to combine. So we're doing here 2 plus 3 plus 2. So I got 2 plus 3 plus 2. That's going to end up being 7. And then I'm bringing down that radical 2. So they all have the radical 2 in common. They're like terms. My final answer would be 7 radical 2. For the second one, same thing. So I look at each term and see that it's completely simplified. So I have a radical 2, a radical 3, a radical 2. Those terms are all simplified. We then look to see what are like terms. So I see a 3 radical 2 or negative 3 radical 2 and a 2 radical 2. Those are considered like terms because the number under the radical is the same. But you can see that 2 radical 3 is not a like term. The number under the radical is different. So then we're just going to simply add and subtract those coefficients. So I have radical 3 plus 2, that's minus 1, and then I bring down the radical 2. And then 2 radical 3 doesn't combine with anything, so I'm just going to write it down. And then you might see your answer where we don't write that value of 1 because we assume it's there if we don't write it. So our final answer would be negative root 2 plus 2 root 3. And then we would be done. For the number 3 and 4 are very similar. It just has a little more work we have to do, right? So again, we're doing the same concept. I'm going to take a look. There we go. So I'm going to take a look at each term and see if I can simplify. So if I look at the first term here, and I'll make this a little bigger, we actually end up having the first term doesn't simplify, so I would just bring it down. The second term actually does. The square root of 54, I can simplify. So even though it looks like I don't see any of the root 54s, I might have a like term after I simplify it out. So 54, the largest perfect square that goes into 54 is 9. So it'd be 9 times 6. Or 2 times 3 root 6. Or 6 root 6. And then the last one, I have 2 root 27. 27 would be 9 times 3. Or 3 radical 3. Or 6 radical 3. And so if I now look at the problem kind of like the one above, I'm going to see, do I have any like terms? I do. I have 2 radical 3's right there. So I'm going to go ahead and combine those together. So when we go ahead and do that, negative 3 plus 6, I'm going to get 3 radical 3, and then I'm going to bring down the 6 root 6. And that would be my final answer. So we had to simplify all the terms first and then combine like terms. For number 4, it's basically the same thing. So I'm going to go ahead and simplify. What simplifies? So 2 root 20 would become 4 and 5. Or that would be times 2 root 5 or negative 4 root 5. I'm now going to do the same to 2 root 18. 18 is 9 and 2. And then the last one, 2 root 45. 45 is 9 and 5. Make sure I'm going to write this a little nicer. So we get 6 root 5. And now I'm going to go ahead and see what like terms I have. So 4 root 5 and 6 root 5, I could actually put together. So we would get 2 radical 5 plus 6 radical 2. And that's as far as we can go. So with adding and subtracting, you'll just simplify and then put like terms together. For the last part we're going to look at is talking about solving equations, right? So we're going to see a little bit of solving radical equations. You'll see this more throughout the year and then throughout, obviously, a little bit maybe in math too. So the idea with it is we get the radical by itself first, and then we do the inverse, right? So we undo square rooting by squaring. So in this first one, I see that I have root 25x equals 5. So I'm first going to get my square root by itself and my radical by itself. It already is, right? So I have it isolated on its side by itself. And then now we're going to do our inverse. So what that means is if I want to undo square rooting, I'm going to square both sides. So on the left side, I'm going to get a 25. On the right side, the radical and the square undo each other, like, right? So they're inverse operations. So I'm left with whatever's under the radical, which is just the 25. And so I have 25x. And then we're going to go ahead and divide by 25. And x would be equal to 1. We then want to make sure when it says check for extraneous solutions, sometimes algebraically we can get an answer that doesn't make sense because we're not allowed to have negative numbers under the radical. So when I go ahead, if I was to substitute this back in, I actually get, it was at 25 times 1. I get 5 equals 5, and it actually checks out. So I am allowed to get that as a solution of x equals 1. For number 6, I'm going to do the same exact thing. We're going to go ahead and get our radical by itself first. So I see a 3 out front. It's very tempting for students to want to subtract 3, but actually the 3 is multiplying the radical. So I have to undo that by dividing by 3. I'm going to get 3 equals root 3 minus b. I have the radical by itself, so I'm going to square both sides. And I get 3 minus b. And then now I'm just solving a linear equation. So we're going to go ahead and subtract 3. I get 6 equals negative b. If I divide by negative 1, I get b is equal to negative 6. And then we have to check that it works. So if I was to substitute this in, 3 minus negative 6, it actually does end up working out. And so I'm allowed to have that as a solution, right? Or if I had a negative under the radical, I wouldn't be allowed to use that. And then finally, the last two, Same thing. So this next one, you can see, even though it's a fraction, same thing. I'm going to go ahead and isolate my x squared first, or my square root first. So I'm going to divide by 7 because that's being multiplied. Okay, I'm now going to undo the square root, but you might have found that you can even evaluate the 9 if you want to. I'm just going to follow it the same way we've been doing it. So we get 25 equals m over 9. And then we can undo m over 9, undo divided by 9 by multiplying. Okay, and if I go ahead and do 25 times 9, I'm going to get 225. And if I was to substitute that back in, I do get an answer that would work. And then finally, the last question, same thing. We're going to go ahead and isolate our radicals. So I'm going to go ahead and add 9 to both sides. I get a 2. I'm going to square both sides. And now it just becomes a linear equation. We're going to add 2, divide by -3. So P would be -2. And then we would go ahead and just check it in that it actually works, right? So -2, -3 times -2 would be +6. And it actually does check out. And then that would be it.